My name's Michael Green. I'm an associate professor at MD Anderson Cancer Centre, and together with Dr. Chris Flowers, within our department, we have a project that is jointly funded by the Mark Foundation and Follicular Lymphoma Foundation, focused on the follicular lymphoma microenvironment. In that project, we're using an exciting new technology called spatial transcriptomics, which allows us to take a slice of tumor and essentially look at gene expression within every single cell so that we can define that cell state and then look at neighborhoods, the arrangement of cells into communities and how they communicate together to drive disease biology. This is important because recent developments in follicular lymphoma therapy include what we would collectively referred to as immune engaging therapies, things like cereblon modulators, bispecific antibodies, and CAR T cells. And we think that the baseline state of the immune microenvironment is going to be highly predictive for how patients respond to immunotherapy. So we're defining this in hundreds of patients and hoping to prospectively use this to select patients that are most likely to respond to several therapies. Our project sets the stage for escalating digital pathology in lymphomas generally. Digital pathology is an exciting new area where we can apply artificial intelligence. To summarize it, we can scan typically stain slides. So we do a stain in pathology called hematoxylin and eosin, or H&E. Everybody does this. We can simply scan those slides in and then use AI in order to predict the immune microenvironment. So if we do this en masse for patients, we can discover different biological subsets of patients that might respond better or worse to certain therapies and allow us to personalize the therapies that we give to patients such that they're most likely to have really long-lasting, durable responses or even cure. To move towards a cure, I think we need to take a more integrative approach to understanding follicular lymphoma biology. Historically, we've been very focused on the tumor cell, specifically with tumor cell genetics and understanding what different mutations do to the tumor cell itself, without really taking into account how the microenvironment influences the tumor cell and interplays with genetics. So what this gives us the opportunity to do is develop a more holistic understanding of follicular lymphoma biology in such a way that we may be able to develop therapies that target not only the tumor cells themselves, but the microenvironment and ultimately drive a cure.